Okay, so welcome back. So we're now going to have the second keynote speech by Professor Martin Uribe. So we think there was a change in the program, so thanks for flexibility. And then we're going to have also a presentation that comes next by another Martin in the program. So one thing that we can learn is that our names are Martin and not Martin. That's something we can't believe on. So just a very brief introduction. So Martin Uribe is a professor of economics in Colombia and has contributed very extensively to the fields of international macroeconomics, and private finance. I mean, everyone here knows very well his contributions, and actually throughout these 2 days we see many papers that were cited in very important influential papers writing by Martin. So in that sense, I don't think he needs much more introduction. He's also had been very active in services to the profession other than producing high-level research. He's currently the chief editor at the Journal of International Economics. He also published 2 books, per macro, 2 textbooks. So also trying to show, an impact that is wider than his own research. Argentina. He's Argentina, and Argentina is a country with many, many puzzles, and one of those is that we have produced a bunch of very, very well fine and overperforming economists, and we have produced a very highly underperforming economy, as everyone knows. And I think Martin is also had devoted many efforts to solving that puzzle. He's very active in the debate in Argentina through media and panels, trying to make sense in a country where things tend to not make sense a lot, and that, I tell you, is something can be very energy consuming and frustrating at times, but that I think is very important to highlight. And today Martin is going to present a paper joined with Stephanie Schmidt-Grohe, which also reflects, I think, to a long extent the spirit of this partnership between the Banque and Paris School of Economics in rigorous research, data-driven, that can help understanding better the world, to diagnose and maybe having better policy decisions, right? So I give the floor to Martin. To Martin. Okay. So you have 1 hour.
This speech that I plan to give today is about what long-time series can reveal about about R star. I thought it would be fitting. My reading of the conference is that yesterday the theme was R star, and today the theme is Pi star. So I thought I would talk about that. I have in this paper we have in this speech, because this is a project in which Stefan and I are working on, which is trying to understand R star and Pi star within the uniform framework. And we have 2 distinct questions, separate questions. The first one is, what are the macroeconomic effects of natural rate shocks on output and inflation in the short and the long run? Now, our reading of the empirical literature is that most of it has been devoted to trying to characterize the path of R star, the path of the natural rate. So most papers, the final punchline of those papers is to show you a time path of R star, to show you that R star, for example, has been falling in the past 20 years or so. Now, less work has been devoted in the empirical literature to trying to understand what are the macroeconomic effects of stochastic movements in R star. What does fall in R star, for example, a negative innovation in the natural rate, imply for output in the short and the long run, imply for inflation? And that is an obvious question that is inspired in theoretical models. For example, yesterday we had a model in which the natural rate or natural rate movements were generated from changes in demographics, right? There was a perpetual youth model in which there were people being born and people dying, and that was used as a source of movements in the natural rate. We had another paper yesterday in which movements in the natural rate came from movements in the subjective pure discount factor. And so it's natural to try to ascertain what are the macroeconomic effects of natural rate shocks in the context of an empirical model, of an identified empirical model. So that's going to be one question. The second question, which is separate, is this inflation spike that we had post-COVID, how much of it was driven by the permanent component of inflation, how much was just transitory? And the question is there, what can we learn in both cases from long data? So, with respect to the first question, what are the macroeconomic effects of innovations in the natural rate of interest on output and inflation in the short run? Our finding today is going to be that a fall in the natural rate causes a significant fall in output trend. That is to say, if you think about the trend of the log of output as being a line, that line is going to shift in a parallel fashion downwardly, and that is in the long run. And in the short run, it causes a recession and deflation. Now, what is the interesting part of this result is that this result, these contractionary effects of a fall in the natural rate in the long and the short run happens even when you estimate the model outside of the zero lower bound. Why is that important? Well, because we have a number of models that have shown that the fall in the natural rate can be contractionary in a context in which the economy is constrained by the zero lower bound. But we do not have good models that can explain such contractionary effects in a context in which the economy is not restricted by the zero lower bound. And I think that is something that poses a challenge, because if you think about, say, the neoclassical growth model, a fall in the real interest rate is always expansionary. It's even in the long run, right? It shifts the trend of output upwardly.
But Martin,
yeah.
Wouldn't an exogenous increase in the trend growth rate, say productivity of TFP, just give you this, that trend growth would be lower?
No. Yeah. If you think, for example, of a labor augmenting permanent productivity shock, the real rate of interest is independent of such a shock.
No, but if it's about the growth rate of TFP going down, then the marginal utility tomorrow will be not as high anymore as it used to be, as low as it used to be.
Yeah, the problem is that we don't see,
well, the secular stagnation.
It would be very difficult to explain that with the, continuous fall in the growth rate of that variable.
No, but a one-time shift in the trend growth rate is going to lead to a permanent move in the real interest rate.
Say that again?
A one-time shift in the trend growth rate.
One time, yes.
Is going to lead to a permanent shift in the real interest rate. Okay.
Now, so that is the first set of results. The second set of results is the following. If you compute pi star, that is to say the permanent component of inflation, and you estimate the model over the period 1900 to 2021, and then you get the time path for pi star, that is to say the permanent component of inflation, that you can call it the de facto inflation target or trend inflation, any name you want to give it is fine with me. Let's call it pi star. This is what you find. Between 2019 and 2021, inflation in the US more or less doubled. Right? It went from a little bit more than 2.5, say, to 5, or a little bit more than 5. Now, if you estimate the model between 1900 and 2021, that model will tell you that most of that increase was transitory. Instead, if you cut the sample and estimate the model post-war, say wait a few years after the Second War and estimate the model, say, from 1950 or 55 until 2021, the model tells you that most of the increase in inflation was permanent. Now, why is that interesting? Well, because the post-war is basically dominated by the pre- and the post-Volcker inflation dynamics. That is to say, you have like a volcano that starts in 1960, increases gradually, but until very high levels, and in the early 80s comes the disinflation, and you have the second side of the volcano. And if you try to estimate an output trend, the output trend is going to follow inflation very closely there. Now, the first half of the 20th century is plagued with very sharp spikes in inflation, similar in terms of the slope, these kind of vertical spikes in inflation, like the post-COVID inflation. So when you estimate the model over a long period of time, the spike post-COVID is associated with the first half. The model says this looks like the big spikes in the first half. So it attributes everything to the transitory component of inflation. But if you estimate the model on the second half only of the 20th century, when you only had this gradual increase in inflation, where most of the increase in inflation was trend inflation, most changes in inflation were explained by trend inflation, it is also going to explain the 2019 to 2021 inflation with the permanent component. So in that sense, we think that to try to understand this very unusual post-pandemic increase in inflation, it is useful to use long data. So that is what we learned from this research. Okay, so the model we are going to, any questions? The models we are going to use is going to be a cross between a DSG and an SVR model. It's going to have SVR features in the sense that it's going to have few cross-equation restrictions, minimal amount of cross-equation restrictions or identification restrictions. And it's going to look like a DSG model in a bunch of aspects. First of all, we are going to have more identified shocks than observables. We are going to have a model in which trend shocks are going to affect the cycle, and trend shocks are going to live together with stationary shocks. That is going to allow us, in particular, to understand movements in the permanent component of inflation, of the real interest rate, which is R star, on variables such as output and inflation. So the model is going to have three endogenous variables, which are going to be output, inflation, and the nominal interest rate. It's going to have, so output is going to be YT, inflation is going to be pi t, and the interest rate is going to be IT. It's going to have three permanent shocks. One, say, labor augmenting productivity shock, which is going to be called XT. The natural rate shock, XR, which would be R star. I don't know why we called it XR. And a permanent monetary shock, which would be pi star, which we call it XM, right? So X is like a neutral but permanent productivity shock. XR is the natural rate shock, also permanent, non-stationary. And XM is the non-stationary monetary shock. And then we are going to have two stationary shocks, which are going to be called Z. ZM is going to be a stationary monetary shock, and Z is going to be a real stationary shock. Okay, so we are going to have three endogenous variables, 5 shocks. And the idea is more or less to recreate, in the context of a not too structured model, the same idea we have when we estimate a DSGE model. That is to say, to create a rich set of shocks that will be then competing for trying to understand the variance of a bunch of time series. In this case, 3 time series. So we are going to have those those 5 shocks competing for understanding the statistical properties of those 3 observables. So this is the model. So YT is output, and we are going to assume that output has a trend that is driven by this neutral productivity shock, this non-stationary productivity shock called XT, and by the natural rate shock, the non-stationary natural rate shock XR, multiplied by this parameter delta. So if delta is positive, then a fall in the natural rate, a fall in XR, causes a fall in output trend. So delta is going to be a key parameter there. And then, so if I subtract from YT this trend, XT plus delta XR, I get Y hat, which would be the cyclical component of output. So the hatted variables are all cyclical components. Then we have inflation, pi t, that is going to have a trend inflation, which is going to be XM, that would be pi star, such that if I subtract XM from pi t, I get pi hat t, which is the cyclical component of inflation. And in the case of the nominal interest rate, the trend of the nominal interest rate is going to be also XM. It's also going to be co-integrated with the nominal permanent monetary shock, but it's also going to be co-integrated with R star in a natural way. So if I subtract XM plus X star from IT, I get I hat t, which is the cyclical component of IT. So now I have the 3 hatted variables, Y hat t, pi hat t, I hat t, and we are going to assume that that vector of cyclical components follows an autoregressive process whose driving force are the growth of the trends. That is to say, the trends are going to have an effect on the cycles, plus it's going to be driven by these 2 stationary shocks, the monetary shock, ZM, and the real stationary shock, Z. And the matrix multiplying that is going to be C, right? So that is the evolution of the cycles, right? The autoregressive matrices are the, in this case, it's an annual model, so it's going to be B, the autoregressive matrix, and then the matrix multiplying the driving forces is going to be C. And then exactly as in the DSGE literature, we are going to assume that those driving forces follow an AR1 process, right? So that is the second equation here, and the rho is a matrix of 5 by 5, which is diagonal, and the same is with phi, right? So the matrix B is 3 by 3, the matrix C is 3 by 5, and then rho and phi are 5 by 5, diagonal.
The variance of these shocks is constant over time?
Yeah. Yes, so this is a linear model. Okay, let me talk a little bit about identification. I already talked a lot about identification because I told you exactly how the trends are identified, right? So X, this productivity shock, is the only permanent shock that is co-integrated with output and not with the other variables. XR is a shock that enters in the co-integrating relationship with output and with the interest rate. And then XM is a permanent monetary shock that enters in the co-integrating relationship of the two nominal variables, pi and I. So those permanent shocks are identified in that way. And then to identify the stationary monetary shock, we are going to restrict the coefficients in the matrix C. So the ZM, the stationary monetary shock, is the second element in the driving force of the first equation. So the coefficients multiplying that shock at the second column of C. So we're going to assume that those stationary monetary shocks, as is usual in the literature, don't have an impact effect on output and inflation. This is an annual model, and this assumption that monetary shocks don't have an impact effect on output and inflation is typically made in models that are quarterly. So one might wonder, is it reasonable to do it in the context of an annual model cast in annual frequency? And we are comfortable doing that because if you look at the quarterly models that make that assumption, and you see the input responses of a monetary shock, those shocks take very long until they start kicking output and inflation. It takes a long time. So we kind of feel comfortable with that. But just in case, we also have an identification scheme in which we allow those two first elements of the second column of C to be non-positive. It requires additional restrictions, but that is basically what we do, and the results are robust to that. So that's the model. If you if you're with me with this structure, you are with me throughout the paper. So basically, what we want to understand is what are the effects of changes in XR, which is R star, on output and inflation in the short and the long run, and what is the time path of XM, the permanent component of inflation. That is our goal. This model cannot be taken as is to the data because we don't observe any of the variables in the model, right? We don't observe the cyclical components, we don't observe the shocks, we don't observe anything. So as is usual in this kind of analysis, did this froze? Oh, here we are. There we are. We have observation equations, which are nothing else than saying, okay, let's pick variables that we can observe and for which the model has precise predictions and link them to the variables of the model. So we are going to assume that we econometricians can observe the growth rate of output per capita. So we observe delta Y. We observe the change in inflation, in CPI inflation, delta pi. And we observe the change in the nominal interest rate. And then these observation equations are basically identities. So for example, the growth rate of output, of real output per capita, is the growth rate of its cyclical component, that is to say y hat t minus y hat t minus 1, plus the growth rate of the trend. And the trend of output is xt plus delta xr. So it would be delta xt plus delta xr. And the same with other variables, right? The change in inflation is the change in its cyclical component, pi hat t minus 1, plus the change in its trend component, which is delta xm. And similarly for delta it. And we are going to assume that the econometrician observes the growth rate of output, the change in inflation, the change in the nominal interest rate with some measurement errors, which are the mu's on the right. Okay, so that is essentially the model. I didn't show you intercepts because they're not essential to what I want to say. Okay, so the point is that once you know this, since the model is linear, we know exactly what is the stochastic distribution. We know the probability distribution of the right-hand side variables. They are all linears and they are Gaussian, so we know that. So we can easily compute the likelihood of the data. That's the idea, right? The usual idea. Okay, we do, and once you know the likelihood of the data, you can do all sorts of estimation, right? You can do classical estimation, Bayesian estimation, and so on. We do Bayesian estimation, which implies that we have to have some priors. I'm not going to walk you through the priors because they are pretty standard. We basically follow the Minnesota prior and gamma distributions for the standard deviations, beta distributions for parameters that are in the range 0 to 1, for example, the rho, the persistent parameters, and so on. The estimation is going to be with long data from 1900 to 2021. It's going to be annual data. And we are going to use the Metropolis-Hastings algorithm, which, this model is very simple. It's linear, it's small, but the parameters, the likelihood is a very nonlinear function of the parameters. So I always say that this model should be, you have to draw a lot from these models always to make sure that you are really getting the right distribution. Now that computers are fast, you can do a lot of that, especially because the Metropolis-Hastings algorithm is not the most efficient of all. So if you have a fast computer, go ahead and do a lot of draws from the distribution. We do really a lot. We could have applied more efficient techniques, but we went with this. Okay, so let me go right away to the results so that we can have a discussion later. So this is our umbilical cord, if you want, with the previous literature, right? This is where the previous literature ends. All the papers on R star that are empirical end with the path of R star. We start with the path of R star. So this is the path of R star in blue, which in this model is called XR. And what do we learn from the long data? And I'm not saying that this is the main contribution of the paper, but it's worth discussing it here with you, is first of all that R star is doesn't have a monotonic path over the 20th century and whatever we have of the 21st century. On the contrary, if you're familiar with commodity prices, this looks like a super cycle. In the commodity price literature, there's this whole idea of super cycles. This looks like a variable that has a super cycle. In particular, the first thing that jumps is that the fall in R star that we have seen in the past 25 years is not a unique phenomenon. We had a cycle, for example, started in 1900 with a downward trend until the beginning of the Great Depression, then an increase until the mid-Second War, then some movement there, and then what we are seeing now is the downward side of a cycle that started in 1960. Right? In 1960, it was building up until it reached a peak in the late 80s, R star, and then started falling. Now, why is this important? This non-monotonicity, why is it important? Well, because, just to give you an example, there are theories that try to explain the last 25 years with demographics. For example, population is getting older. Life expectancy is getting longer. Well, life expectancy has been increasing in the US since 1900. Except for big crises like the Great Depression, where there was a lot of hunger, and that affected fertility and so on. But if you look at trends, mortality has been falling for more than a century. Life expectancy has been increasing for more than a century. So I think that this non-monotonicity is an important kind of thing to take into account when it comes to discriminating theories. I'm not saying that demographic issues are not important, because, for example, you could say, well, yes, life expectancy has been falling, but for different reasons, right? At the beginning, life expectancy increased because we found ways for babies not to die. Now it is increasing because we are finding ways for people not to die too young, to live longer, getting closer and closer to 80s and 90s in life expectancy. So that is, I'm not saying that is not important, but what is important to have in mind is that this is a non-monotonic path in our star, and that poses a challenge for the theories we want to use to explain it. Okay, but as I told you, that is our starting point. That is not really where we were really wanting to go. But
Martin,
yes.
No, very quick question. Why the interval is much narrower between the 40s and the 60s? The estimation is better, right? More precise. And then increases.
Yeah, it could
be.
Do
you know why or what that means? Or?
I honestly, I don't know, really. That's a good question. My prior would have been that it should be the other way around, right? But, okay. This is really where we are going. The two questions I posed today, and I'm going to show you just one picture for each question so that we can wrap it up quickly and then discuss. The first question was, what are the macroeconomic effects of exogenous movements in our star? Which is a question that I think in the empirical literature has not been addressed. And I summarized that with these impulse responses. So this is an impulse response to a fall in our star, which here I insist is called XR, a fall in XR that in the long run lowers the natural rate. So XR goes in the long run to -1 percentage point. And the first impulse response, the element 1,1 of this matrix, of this 2x2 matrix, is the real interest rate, which is not R star. R star is the permanent component of the real interest rate. And what happens with the real interest rate is that when R star falls, the real interest rate falls and then keeps falling until, of course, at the end it has to join R star, right? In the long run, R and R star are the same thing, because R star is the permanent component of R. Now, the most interesting impulse responses are the second column of this matrix, right? So, for example, element 1, 2 is the impulse response of output. And what you see in the impulse response of output is that when R star falls, output falls on impact. So there is a recession on impact, and then output keeps falling. So output falls not only in the long run, but also in the short run. And in the long run, it falls by a lot. If you look at element 2.2, which is inflation, when R star falls, inflation falls, and then increases, but gradually towards 0. So that the result of those two, of that second column, is that a fall in R star causes a fall in the trend of output. So there is a permanent fall in output, but also a recession in the short run, and also deflation in the short run. So R star is deflationary and contractionary in the short run, and it's also contractionary in the long run. Now, this graph, if I exclude the ZLB periods, since 1900, there were essentially two periods of ZLB. One prior to the Second War, and one after 2008. And if you want the intermezzo, also the COVID part would be a second period. But let's say everything after 2008 and everything below or before 1946, if you estimate the model outside of the ZLB, these impulse responses look very similar. They don't change much. They look like this. And that is, to us, kind of puzzling, I think, to get these impulse responses in the context of a model in response to an R star fall is a challenge outside of the ZLB. Within the ZLB, we have tons of models. Call it secular stagnation models, call it ZLB models. We have a lot of models that can explain phenomena like this one, but doing it outside of the ZLB, I think, is a theoretical challenge that we are not going to touch upon, at least in this paper.
Can I ask a question?
Yes.
I'm struggling to understand the interpretation of output responses. So does this mean, permanently speaking, output is 10% lower as it would be without the drop in the natural rate?
Yes.
So how do I think then about the long run growth rate? Does this the trend growth rate?
In this model, R star has trend effects on output, but not growth effects.
So the growth rate would be the same, right? So
the growth rate would be the same, because I don't think I mean, I shouldn't be talking here because I think Ascari Guido left, right? It would be good to have a discussion with. Where?
Here.
Sorry. Speaking of your life, I was looking for you. Where is he? So, you know, one thing that I would comment on Guido's paper is that I don't see, and what is reassuring is that you said that even if you assume that output is I1, your results are robust, right? Yeah. Because I have problems assuming that Y is I2, in the sense that if I look at the growth rate of output, just do something very simple. Compute the correlation of output growth. The serial correlation of output growth is way below 0.3, I would say, something between 0 and 0.3. So it's very hard to come up with a story in which, and this goes back to Adam, the first question, right, Klaus, where you say, okay, I want to have a model in which it is permanent changes in the growth rate of output that is doing the trick. Well, for that, you have to empirically convince me that output growth is non-stationary. And that, I think, is a very hard thing to do, because output growth is almost serially uncorrelated. So that is the kind of challenges that I think, from a theoretical point of view, these kind of results pose.
He's escaping.
Non-stationary?
Yes. The natural rate is clearly non-stationary. I mean, if you look at this graph, it's very hard to have a, when we think about random walks, or a random walk component, the typical random walk component time series we have in macro, at least. I don't know in other fields, but in macro they look like this. Yeah.
I mean, the fact that serial correlation of output growth is very low, certainly
isn't implying that there couldn't be a small I2 component, right? If you have an integrated, so you have small shocks to the trend growth rate, and that should, according to your logic, produce positive autocorrelation in the trend growth rates over time. But now you add some IID level shock to that, and that's going to superimpose a negative autocorrelation at short frequencies. So the short frequency autocorrelation isn't really informative about whether or not I2 components are there.
I told you as a very rough, I told you, just roughly speaking, just look at that as a first pass.
So are you using output per capita?
You're gonna have a very small random walk component, and that's what you're gonna have. Yeah. That's what you're gonna have. Okay, so any other questions about this one? So, second question, what drove the COVID-19 inflation? Was it a permanent component or was it the transitory component? So for that, I'm going to show you pi star. So this is XM, the permanent component of inflation, together with the actual inflation. So the blue line is the trend of inflation, pi star or XM in this model, and the broken red line is the actual inflation. So what does this graph tell us? What this graph tells us is the following. If you look at the second half, which is what we are most familiar with, right? Anybody who has computed the trend of inflation is very familiar with the second half of this graph, right? The post-war period. What you see is that it's dominated by this build-up of inflation from the 60s, and then the disinflation that started with Volcker and continued with the Great Moderation. And what is characteristic of that? Well, that trend inflation and actual inflation moved in tandem, moved very, very, very closely. Whereas in the first half is littered with spikes in inflation, very sudden spikes in inflation that the model interprets as transitory, right? So the trend of inflation follows actual inflation much less in the first half of the century, of the 20th century, than in the second half of the 20th century. Now, if you look at the very, very end of the time series, which is the years I'm interested in, 2020 and 2021, the increase in actual inflation was almost vertical, which the model says this looks very much like the spikes pre-war. So I'm going to give it all to the transitory. That is what the model is saying. So if you see the blue line doesn't follow the broken red line in the last 2 years. Now, what happens if instead I were to do what we always do, which is to forget long data and do post-war? That is what I have been doing forever. Well, if I estimate the model with that data, well, we don't have much. What the data tells us is the trend should follow actual inflation. So what does the model say for the 2020-2021 inflation? Well, the model should follow actual inflation, and you give all of the actual inflation increase to the permanent component. Now, I think that this particular case, I know that we have been doing post-war forever, but in this particular case, post-pandemic there is a reason not to stay with the post-war data, because the pandemic was a very unusual. We are still trying to sort it out. It's a very unusual situation that we didn't have in the post-war. In the pre-war, we did have episodes like this. We had, including a pandemic, by the way, and including the inflation post-pandemic. But we also had other crazy situations, enormous droughts and problems in the farming sector and crisis and so on. So I think that to understand that period, it's better, at least there is some credence for using long data. So I'm going to stop here and conclude. I started with two questions. What are the macroeconomic effects of natural rate shocks, which is a question that in the context of empirical models have not been studied. And what we obtain is that a fall in the natural rate is contractionary, not only in the long run, but also in the short run. And on top of that is also deflationary. That result obtains also outside of the ZLB, which in my opinion poses a theoretical challenge for us. And if you say, okay, what does the exact model tell us about inflation in the past 2 years? Well, it tells us that it depends how you estimate the model. If you estimate the model using long data, it's going to attribute the inflation in the last 2 years to the transitory component. So it says this inflation is transitory. If you estimate it with post-war data, in which you don't have a lot of spikes like the COVID-19 spike, it's going to give it to the permanent component, because that is what happens in the post-war. The permanent component followed actual inflation, so it naturally gives it to the permanent component. Okay, so I'm going to stop here so that I don't abuse your time. Thank you for your attention.
Thanks so much, Martin. I love your final result on the differences on inflation. I was just wondering about the interpretation you make of it. One big difference between the early 20th century sample and the late 20th century sample is the difference in monetary policy. It was on the gold standard, and then maybe the current monetary policy is closer to the one of the 70s. So I was wondering how you think about this, and whether it's not an argument also to trust estimation on the shorter sample.
Yeah, I mean, that is something that we have to live with when we do, empirical analysis. If you look at the post-war period, it is rich with different monetary regimes. I mean, remember the Bretton Woods, which was like gold standard version 2, right? 2.1. Was abandoned only in the early 70s. So the post-war data had many years in which monetary policy was some sort of gold standard, Bretton Woods, and a gold standard version 2 that at the end was kind of degenerating into something. What it was, I don't know, when the economy started to get unanchored, what regime was that? I mean, what was the regime post-Volcker? So we had gold standard after the war, version 2, then it degenerated into something, then came Volcker with the disinflation, then came Greenspan, and then came Bernanke saying, let's throw everything to see what happens. And so I wouldn't say that the post-war is a clean experiment in which we use it because the monetary regime was constant. No, we use it because it's the post-war period and we are familiar with that period. And because we didn't have reasons to use the pre-war period, right? I mean, during the Great Moderation, we didn't have to look at the volatile pre-war. It was too volatile for us. We said, we don't understand that. Now, if we want to understand something that we don't understand, which is the post-COVID, I think it makes more sense to go back. That's my take on the money. But you're right. I mean, this is a very natural question to ask, right? To say, look, over your estimation period, monetary policy has changed a lot. Well, unfortunately, that is the case. Yeah.
Thank you. What's the story to tell to government in Europe government in Africa, elsewhere in the world. You know, beautiful equation, beautiful, air star, etc. I'm wondering if there is some connection to do between these beautiful equation, these new knowledge and decision making. Nowadays in Africa, Bretton Woods, World Bank, IMF are in the troubled water. Have you something to tell them about inflation, about what we go from there?
You mean about developing countries, eh?
Yeah, why not? Asian country, everywhere. We are in troubled waters today, and we are like thinking in our ivory tours.
Well, so my take on this is the following. And here I'm going to be speculative. If you read the papers that are coming on environmental economics, for example, what they are trying to hint, what the picture you are starting to get is that it's not unreasonable to start thinking that the nature of the business cycle is going to change as a result of climate change, for example. So that post-COVID type fluctuations might be what the future is having for us. That is what we are starting to get from the new papers that are being written on environmental aspects of the business cycle. Now, if that is the case, then we are going to have to learn to model time series that are very volatile. And that gets us closer to what happens in emerging countries, right? I mean, when someone asks me, what is an emerging country from a business cycle point of view, I always say, as a first approximation, if you want me to tell you one line, an emerging country is a country that has twice the volatility in output than the US. That is an emerging country. So, I don't know, I'm more optimistic than you in the sense that I think that this kind of framework, I'm not saying that it's applicable, translated like verbatim to an emerging country, but it's not a bad starting point to try to think about trend shocks more seriously, right? To say, okay, how can I introduce trend shocks affecting the cycle in a model that doesn't require to put too much structure, right? That I don't have to do sum beta to the t, u of ct, and put it exactly in the budget constraint and so on, to have a little bit of a looser structure to tell us what are the challenges we have to come with when we go and write the model sum beta to the t, u of ct, right? I see this as a preliminary step in that sense.
There's a question here.
Yeah.
So on your second point about the inflation spike being permanent or transitory, there is a related paper by Mike Kiley which makes kind of a similar point for looking at longer data, although he only considers post-war data and he's comparing the Great Moderation period with the entire post-war period.
Yeah.
And his point is that what may have happened is that the Phillips curve maybe has a steep slope, but in the second period, because of inflation targeting and whatnot, a different regime of monetary policy, we simply didn't see that slope. That it made inflation was essentially constant plus noise, a small noise. And now with the new strategies of the Fed and the ECB and so on, we may be back to the 70s regime where, you do see the slope of the Phillips curve and therefore you get back the inflation So I think it's an interesting paper that complements your point.
Yes, I totally agree. I think that is a good way to look at it.
I think there's one more question. Okay.
Yes, thank you. Thanks for the fascinating, interesting presentation. When you estimate the model over the longer sample period, you see a lot of fluctuations in the permanent component of inflation during the before the war, after the war. So how do you interpret this permanent, this relatively fast movements in the permanent component of inflation over that sample period? Coming back to your introductory remarks also that demographics is not really the driving force. Can you...
Are you talking about this?
No, this one, yes.
Yeah.
So the natural rate fluctuations seem to be rather volatile. So what if it, like, can you give us a little bit of insight of telling us what you think could be the drivers in these fast movements?
Well, so when you look at the short run movements in trends, in trends, well, that could be due to a number of factors. For example, in the first half of the century, it was not unusual that Americans go to bed hungry. And a population that is hungry is a population that's going to have fertility issues in the short run. So if you look at, for example, movements in fertility, the recessions do affect fertility. And you had, just to give you an example, I'm not an expert in what could have been causing those movements pre-war. But you know, there are a bunch of factors. I don't know, I don't have a very important theory about beta. We had a paper yesterday about movements in beta. I don't know what could be driving beta, for example, fats, right? Things like that. But I mean, when I think about these things, I think about those issues. That's the kind of flavor that I could give you, which goes back to the other question about Africa, right? I could imagine. I mean, I haven't seen a graph for R star for an African country, but I could imagine that R star would have, you know, movements of the type that we saw in the first half of the 20th century for the United States.
We are on time now, so
Excellent.
I will frustrate some people that raise their hands, but maybe we can, you know, we have still a coffee break. We can go over it. So unless you want to wrap up, say something else. Okay. Well, thank you very much.